Everyone likes a vacation in a warm climate. But how about a trip to two planets that are as hot as hell?
If you were walking on the surface of Mercury, you'd need one heck of a spacesuit.
Mysterious Mercury appears lifeless and desolate, but hidden deep inside is a clue to a different past.
The smallest planet made out of the densest stuff with the most lunar-like landscape at its surface and yet generating magnetic field.
It's a planet that's part furnace, part freezer.
As you get to the higher latitudes on Mercury, the ice is contained in places where literally the sun never shines.
But it's nearby Venus, goddess of love, who will really melt your heart and crush your defenses at the same time.
So this is the hell, real hell.
Once the twin of Earth, something went wrong here. Terribly wrong.
At some point, Venus had an ocean's worth of water that is now gone.
What turned Venus from paradise to pressure cooker?
I like to use that word alien with Venus. I think Venus is the most alien planet we have.
Could this really be our future?
The ultimate fate of the Earth is to look like Venus looks today.
And here, on our own doorstep, there is possibly the greatest survival story of all.
There's some speculation that Venus might actually still harbor life, even though it is such a hostile place.
There has never been a better time to boldly go where no human has gone before. To follow in the footsteps of our robot pioneers and visit the planets of the solar system. Ever wanted to be an astronaut? Imagine it was you who was heading to the hot zone of the two inner planets. Where would you go? What would you see? And how would you survive?
And liftoff.
The latest robotic missions have revealed more about these worlds than ever before. Armed with this new knowledge, think of this as your personal travel guide to our near neighbors. As the planet closest to the sun, Mercury is the ultimate summer vacation. Step out of your spacecraft, and sizzling temperatures are guaranteed for a day that lasts 3 months. And when the sun finally does set, the nightlife begins with a unique cosmic light show. This is one pockmarked planet worth taking a closer look at. Like our moon, Mercury is covered in craters.
You can't look at the moon or Mercury without seeing impact craters.
It's a good thing Brett Denevi loves a big impact. As a member of the imaging team on the current Messenger mission to Mercury, she sees a lot of them.
What's exciting for me is I get to be one of the first people to see these images of, places on the planet that we've never seen before.
Most people come here to Meteor Crater in Arizona to see a big hole in the ground. Brett's desires run deeper.
If you want to study impact craters on Mercury, this is the best place to come. I mean, this is the most well-preserved impact crater on Earth. It's the closest you're going to get.
Wonder what it would be like to take a stroll on Mercury? You can walk around Meteor Crater in about an hour. But on Mercury, you wouldn't know when to stop. Craters here stretch as far as the eye can see.
If you were sitting on a crater on Mercury, this crater would be a pretty young one. And you'd also have craters on top of that one. You'd have craters all the way down. I mean, even like just the little rocks here would have smaller craters on them. And then, you'd probably be within a big giant crater too that you wouldn't even be able to recognize.
Apollo 11, this is Houston, radio check, over. Contact light.
Although no human has ever set foot on Mercury, we have a pretty good idea of what you would see.
We copy you down, Eagle.
If you were walking around on the surface of Mercury, it would look outwardly a lot like the moon.
When you step onto Mercury, you step into a world with no real atmosphere, where the sky is as black as night and ablaze in sunshine, and where a drive is an off-road trek through at least a 3-billion-year-old battlefield.
Big craters, small craters, craters everywhere. So that's your first impression looking at it.
Like the moon, Mercury took most of its battering early on. A silent witness to the dawn of time, it's been undisturbed by a single drop of rain or breath of wind ever since.
For the most part, the surface of Mercury has been frozen in time for periods of billions of years. And you may say that's boring, but not necessarily. It's a good thing because these planets, such as Mercury and the Moon, preserve a record of what was going on during this critical early period of the solar system's formation. And so we can basically study it there because it's laying right on the surface.
Every stone and crater of this pockmarked world has the potential to gaze back 4.5 billion years. But counting these craters is just the first challenge when it comes to revealing a planet like Mercury.
It's always low on the horizon, so it's hard to point a telescope at it from Earth. It's hard to get into orbit around Mercury because it's so close to the sun.
For that reason, Mercury remains one of the most underexplored planets in our solar system. Many aspects, like its geological past, are a mystery. But some things we do know. This lonely planet has a strange sense of keeping time. Once you arrive, you'll have to reset your watch for a time zone like no other.
It has such an unusual orbit and rotation period. The days and nights are very strange.
A Mercurian year is just 88 Earth days long, thanks to its quick sprint around the sun. But it rotates so slowly, a single day takes much longer.
The day on Mercury is more like half a year on Earth terms.
Although known to us since ancient times, for thousands of years, we had little idea what the planet really looked like. Then, in 1974, NASA's Mariner 10 sends back the first ever glimpses of its surface.
Pictures can be transmitted to tracking stations and on to the Jet Propulsion Laboratory in California.
Due to Mercury's slow rotation and its elliptical orbit around the sun, when it flew by 3 times, it saw the same half of the planet. So we've really only seen something like 45% of the planet at relatively low resolution.
Hidden in these fuzzy black and white postcards for over 30 years are clues that point to one of Mercury's biggest puzzles. It's been shrinking.
Mercury doesn't have plate tectonics like the Earth does, so we know that Mercury's crust is under a lot of compression. And the only way you can really do that is if the planet shrank. And so you can think of it as the incredible shrinking planet.
As Mariner 10 flies past, the mystery deepens. The spacecraft detects a vast iron core hidden inside.
Mercury's core makes up about 60% of the planet by mass. It's about twice as big as Earth. Why would it have such a huge core for such a small planet? Some people think there was a huge impact. It kind of stripped off a lot of the planet, and now what we're seeing is just the remnant of a once bigger planet.
What's left is a planet load of iron. Many questions about Mercury remain unanswered. Questions a new mission will hopefully solve.
Five, 4, 3, main engine start, 2, 1, and 0, and liftoff of Messenger on NASA's mission to Mercury.
NASA's Messenger spacecraft will become the first probe to orbit Mercury.
Getting a spacecraft into orbit around Mercury is difficult for two reasons: the sun and the sun. The sun as a source of heat, and the sun as a source of gravity.
To sneak past the sun, Messenger is taking a convoluted route, flying past the Earth once, Venus twice, and Mercury itself 3 times to arrive in full-time orbit by 2011.
When you get into orbit, you can end up mapping the whole planet at fairly high resolution. So we will start having a mature and fundamental understanding of Mercury, not only its surface, but its whole chemistry throughout the whole planet. From that, we can unravel to some degree how it formed.
What other secrets are etched into Mercury's ancient surface? Already, Messenger has sent back some curious clues.
Engines beginning.
Arriving at Mercury, there's a list of natural wonders to see, and even a dazzling light show. After Messenger's 3 flybys, we've now mapped more than 90% of the planet. Taken from around 124 miles, these images are the clearest to date of Mercury. And it's not hard to spot a crater of epic proportions, the result of yet another titanic collision.
That's the Caloris Basin, this impact basin. It covers almost 3 million square kilometers. It's one of the biggest in the solar system.
The size of Alaska and California combined, whatever created Caloris almost destroyed the planet.
It was, something in the order of 100 kilometers in size. It could have been a huge comet, or it could have been a very large asteroid. It had a catastrophic effect on the surface.
Shock waves rippled around the crust, buckling it on the opposite side. And near the center of the crater is another spectacular geological puzzle that has experts scratching their heads.
The spider is this really strange feature that's in almost the center of the Caloris Basin.
Oh, the spider, it really annoys me when I hear people call it, because it doesn't look like a spider. How many legs does a spider have? 8, right?
It looks kind of like a 100-legged spider, but it has all of these radiating cracks coming out of it.
Whether the spider is the result of planetary stretch marks or some obscure cratering process, no one knows.
It's a fascinating feature. We don't know how it formed. It's very tantalizing.
Mercury shines as a graveyard of past cosmic battles. But is it as dead as it seems? A wise traveler would tread with caution.
When we're looking at the surface, there's all these craters, and they're pretty much the same structure, you know. They have a raised rim, circular, and so when we see a crater that looks like this one here, it doesn't have a raised rim, it's irregularly shaped. That's always exciting because those are volcanic vents. And so this is the site of a explosive volcanism that's happened. It wasn't just lava flowing out, it was these fire fountaining events too.
We settled a 30-year-old debate about the geological evolution of the planet, stemming from a question that Mariner 10 raised but didn't answer, and that is how important volcanism has been on the history of that planet.
So, for a planet that appears inactive, more has been going on deep inside Mercury than we ever gave it credit for. There's even more occurring above the surface that can't be seen. And it involves the relentless force of the sun. Like Mercury, the Earth takes a beating from the sun's violent temper. Flares, sunstorms, and other solar hissy fits can cause electronic mayhem for the satellites that roam above our heads. Fortunately, the Earth is protected from this radiation by a magnetic shield, a kind of force field generated by our molten iron core.
Planetary magnetic fields shield planets, their surfaces, and their atmospheres from charged particles that are always coming off of the sun.
The auroras that light up our polar skies are evidence of our protective shield at work. Without it, life would not exist here. Visit Mercury, and you'll be visiting the only other planet in the inner solar system with a magnetic field. But its very existence defies explanation.
Now, the mystery there is that in order to have a magnetic field, you need to have an interior to the planet that is at least partially molten. Mercury, one of the smallest of the planets, would have been expected to really have frozen all the way through. And yet we have a relatively strong, very well-defined magnetic field that appears to have a source that's located deep in the planet.
Whatever mechanism is driving Mercury's magnetic field, it's too weak to protect it from the full force of the sun. The solar wind buffets Mercury's thin atmosphere. And in the process, it puts on a light show.
The reason you'd want to go to Mercury as a travel destination would be this night side view, because it's going to be highly unique in the solar system. You have sodium atoms that are streaming off and giving off this yellow light. So you could almost look as like you're standing in a donut of sodium emission.
With the sunrise 3 months away, you'll have plenty of time to sit back and take in the view, framed in a halo of amber light.
In some sense, you could get a very nice light show, and I know people go to Canada to look at the northern lights all the time, and so that would be a reason to go to Mercury.
T-minus 40 seconds, everything looks good for launch.
Not a night owl? Then head into the light. But when you're this close to a stellar rotisserie, make sure you pack plenty of sunscreen. If you want a suntan, you can't beat the dusty sands of Mercury. Stretch out on the ground here, and the sun crackles and fizzes right above you, appearing almost 3 times bigger in the sky and 7 times as hot.
If you were walking on the surface of Mercury, you would need one heck of a spacesuit, because if you were in the sun, it would be extremely hot. You would see an enormous sun in the sky that would just, burn you to death if you, spent any time in it whatsoever.
The Mercury really climbs on Mercury to a toasty 840 degrees Fahrenheit. That's about twice as hot as your kitchen oven on full heat.
At such high temperatures, you have a situation where you may literally have pools of some liquid metals, and you certainly wouldn't want to step on them.
You'll need a bit more than SPF 30 sunscreen here. To escape the heat, you can always head to the dark side, but dress warmly. With virtually no atmosphere to keep the heat in, the temperature plummets to minus 275 degrees Fahrenheit. And it's here in the freezer that Messenger will encounter another puzzle. Can ice exist on a planet so close to the sun?
It was only when the first radar observations of the surface of Mercury were obtained, back in the 90s, that it was discovered that Mercury, in fact, had what appeared to be polar caps in these first radar images.
Some corners of Mercury's polar craters are in permanent shadow. Here, on the most sun-baked planet of all, water seems to survive frozen in eternal darkness.
The ice is contained in places where literally the sun never shines. And so the ice is sequestered in these dark interiors of craters at the high latitude regions.
We found the same thing on our moon. In late 2009, the L-Cross mission crashed a probe into a deeply shadowed crater, confirming ice hidden near the lunar South Pole. Where did it come from? A comet?
It's very interesting because we believe that the water in the Earth, in its atmosphere, in the oceans, and even below the surface, probably came from a similar source. And so part of the mystery of Mercury is to try to find out where the water came from, and maybe that might help us find out where the water on Earth came from.
It may never be possible to send a human to Mercury. But how about a robot? In 2011, when Messenger arrives in orbit, imagine this tough little spacecraft circling a lonely planet a very long way from home. Move away from the sun, and you'd expect things to cool down a little. Venus, the picture of coolness and calm. All pale, beguiling, and cloaked by clouds. But the planet of love is shrouded in mystery. Drop beneath her treacherous veil at your own risk.
T-minus 40 seconds. Everything looks good for launch.
Planning a vacation to Venus? Nothing is as it should be here on our twisted alien twin.
Houston now controlling.
Beneath the clouds is the only planet in the solar system to rotate backwards, and it does so very slowly. The sun, if you could see it, rises in the west and sets in the east. An entire day here lasts for 8 Earth months, which is longer than the Venusian year.
Venus, you can walk around the planet faster than the planet rotates.
The sky above is as heavy as it looks, loaded with CO2.
Venus's cloud cover is mostly made of carbon dioxide. On the Earth, we have the same amount, but it's tied up in rocks like limestones, it's tied up in reefs. On Venus, all that carbon dioxide is in the air.
It's the differences between worlds that are so intriguing. That's because 4.5 billion years ago, Venus and Earth started out as planetary twins.
They were formed right next to each other. They're very close to each other in the solar system. They have similar sizes.
Not only that, we now know that the planets were exchanging material early on, that bits of Earth were falling on Venus and bits of Venus were falling on Earth. So if life started on any of these worlds, it may well have spread among them through these little chips getting knocked off from all the impacts that were happening then, all the big collisions.
You are there on the most exciting, nerve-shattering journey in the history of man.
50 years ago, it was easy for us to imagine Venus, closer to the sun and wrapped in clouds, to be our scorched, tropical sister swarming with life.
There was this picture of Venus as a kind of primitive, steamy Earth, complete with giant tree ferns and dinosaurs.
Altogether, it seemed to us that it should be just possibly even populated world.
In the late 1950s, the space race begins. While America aims for the moon, Russia sets its sights on meeting the neighbors.
Venus and Mars still was in the human dreams to meet the species which could be very similar to us. Venus was even easier than Mars to reach.
But landing on Venus proved surprisingly difficult. One by one, the Soviet Venera probes disappear within the thick Venusian atmosphere. Their last transmissions warning of a world of inconceivably high temperatures and pressure. Persistence and tough Russian engineering eventually pay off. In 1975, the camera on the redesigned Venera 9 finally penetrates the Venusian veil. But what it sees is nothing like the tropical paradise imagined. This is the first ever picture taken from the surface of another planet.
And at the first time, it was returned black and white panoramas of the Venus surface. This images was extremely important because at the first time, we, human beings, had a chance to see with our naked eyes completely different other world. We were very much proud of that.
Most of the Venera photos I don't remember seeing because this was the Cold War, it was the Soviet Union, and I guess the press or even American scientists just didn't pay attention. So it wasn't part of our consciousness in the 70s that the Soviets were doing this. Impressive stuff.
7 years later, Veneras 13 and 14 send back the first color postcards taken under Venusian skies.
It means that standing on the surface of Venus, you will meet absolutely incredible situation. First of all, we will see not the blue skies, you will see red skies, orange in color. This is the hell, real hell.
Hell is a good description. This is what it's like to enter the Venusian underworld, a volcanic landscape ruled by crushing pressure and searing heat. No probe survives here for much more than a few hours, and none have ever returned. What happened to our twin world? Was Venus always as barren and hostile as it appears to be?
One of the most intriguing things about Venus is that we know that at some point in Venus's history, it had an ocean like the one we have here on Earth. There's been chemicals measured in the atmosphere that tell you at some point Venus had an ocean's worth of water that is now gone.
Atlantis, Houston, everything down here looks real good to us.
Where did all the water on Venus go? And what else lies hidden under her veil?
5, 4, 3, 2, 1. Navigation and liftoff of Atlantis.
In 1989, the space shuttle Atlantis launches the Magellan probe toward Venus.
Roger roll, Atlantis.
Roll program initiated about 110 degrees.
After a journey of 15 months, Magellan uses radar eyes to peer through the clouds from orbit. Watching from Earth is Ellen Stofan.
When you have that ability to pick up an image and say, I'm one of the first 3 people, I'm one of the first 5 people to ever look at this piece of ground on another planet, it's such a sense of awe and a sense of discovery.
Magellan's radar strips away the thick clouds. For the first time ever, we see all of Venus laid bare. Welcome to Lava Land.
There are volcanoes of all sizes, from a kilometer across to hundreds of kilometers across. And in that sense, it's not all that different from some areas on the Earth. But on the other hand, it's of course this dry world with no vegetation at all.
It's the sheer number of volcanoes that sets Venus apart. This is a world that has been tortured by fire. Over 1,600 giant volcanoes puncture its surface. It's possible some are still active.
You can see from this globe of Venus, which consists of the Magellan imagery draped over the globe, and then the colors are telling you how high the surface is. So the dark blues are low areas and the brighter colors are high areas. One of my favorites is up here at Ishtar Terra, where we have a continent-sized region, so think of something sort of on the scale of Africa or Australia. And I really wonder if Ishtar somehow isn't the remnant of a very, very early episode of plate tectonics early in Venus's history.
Hover like this over Venus, it would probably look a lot like this.
Mark Bullock enjoys spending time on Venus, at least the version he finds here on Earth.
Hawaii has some of the most spectacular shield volcanoes that are very similar to the volcanoes that we see on Venus.
The huge, gently sloped volcanoes of Hawaii may be impressive. On Venus, there are at least 150, ranging from this size to 10 times larger. But the observant visitor may notice that Venus is missing something.
The whole impact crater situation on Venus is really very puzzling.
With the Magellan images, we see really a small number of impact craters, and it's such a small number, it's about 1,000. Because we know the rate at which impactors come in, we can actually date the surface to somewhere between 300 million and 1 billion years old.
Sometime in the recent geological past, it seems the entire surface of Venus was remodeled. And suddenly,
The surface geology of Venus is different than the Earth, basically because of lack of water. Water is not lubricating that crust, so you don't get plate tectonics. Instead, what seems to happen is that forces inside the planet are trying to move things around, but it can't. It's locked. And then very massive, globally explosive episodes that happen about every 500 million to 1 billion years. So you would not want to be on Venus when that happens, because once something gives way, the whole planet might just basically explode in a sense and turn itself over in a very short amount of time in geological terms.
Oh man, look at this. We can see a river of lava beneath the surface. Imagine that this lava is on Venus. Probably something very much like this occurs either today or in the recent past.
No one can say for sure if we'll ever see an eruption like this on Venus. No one has ever been able to get this close.
One of the really exciting and high level of scientific interest is whether Venus is geologically active today, because there are reasons to think that the clouds on Venus only exist because there is ongoing geologic activity. So this is one of the big secrets of Venus and something that we want to find out.
In recent years, finding the source of Venus's thick atmosphere has become surprisingly relevant for all of us down here on Earth.
500,000 tons of sulfur dioxide spewed into the atmosphere every year.
No one on Earth would like our world to stink like Venus. We prefer oxygen to acid and poison.
You can smell the sulfur. This is probably what Venus would smell like. We could fly above it.
And we certainly wouldn't like to live in a giant pressure cooker turned on high. You wouldn't want to live on Venus, period. Venus is what you get when the greenhouse effect goes wild.
The whole greenhouse effect was not really recognized as a significant effect to influence planetary climates until we went to Venus and found that instead of being at 90 degrees Fahrenheit, it was 900 degrees Fahrenheit. And we said, whoa, what's wrong with this? Let's learn about this. And it taught us about the greenhouse effect.
Ever wondered how alien a planet could be? How bad a climate can get? Try the planet next door. The best way to experience Venus is to hitch an imaginary ride on a Soviet Venera probe.
Well, it would be a wild ride.
The clouds start about 40 miles up, some 5 times higher than the Earth's.
What were those clouds made out of? They're not made out of water. They're made out of a completely different substance. They're made out of sulfuric acid. Everywhere you go, the atmosphere is going to try to eat you away.
As you get deeper, things heat up. The thickening atmosphere allows the sun's heat in, but not out. It's also getting dense. So dense, your probe drops like a coin in water.
As we descended, the surface would gradually sort of appear to us as if we were approaching the bottom of the ocean.
Congratulations, you've arrived on the hottest surface in the solar system. Here, the official temperature is 870 degrees Fahrenheit. Day or night, equator or pole, the searing heat never varies more than a few degrees. And it's why we have so few snapshots from the Venusian surface.
So why is it so hard to bring scientific instruments to the surface of Venus? What about an ordinary camera? There's plenty of light there. Why not just send a camera and take pictures? I've got my NASA-issued spacesuit here, my special Venus suit, and let's take this camera and send it to Venus and see what happens.
Primarily, you don't want to melt. It's such a hot environment that all the electronics, all the power, all the communications have to be very rugged.
Oh, that's cool, though.
Anything mechanical, anything electronic is just an enormous challenge to have it function on the surface. But I think it would be pretty close to what we might think of as hell, you know. We would see heat waves, density variations in the atmosphere, so it would be shimmery.
If this was Venus, what would be different? Well, we wouldn't be here because we'd be molten little puddles of human beings.
And it's not just the heat that you have to bear. All that sky above is really heavy, pressing in at around 90 times the pressure on Earth.
When I was a graduate student, we used to get in conversations about what would get you first, the temperature or the pressure. It would be pretty simultaneous, I think.
To descend to the surface of Venus is the same as diving over half a mile underwater.
It's an enormous pressure, enormous crushing pressure. How do you make things that withstand? How do things turn and move under those huge outside pressures? Well, that's what the armor of technology is all about. The exosuit using composite fiber and strong aluminum alloys and stainless and titanium and all these things, it looks like something out of Transformers or out of a comic book. That's the same kind of suit that you'd need on the surface of Venus.
You'd never guess the dangers on the ground from orbit. Except maybe for this, massive, double-barreled storms hovering above the poles.
Of these, what we call dipole features twirling around. We don't know really what they are, but the whole feature itself is only 1,000 or 2 kilometers across. It's not very big, but it has like a figure 8 type of look to it.
Believed to be created by winds that roar around the equator at speeds up to 230 miles per hour, these hurricanes can split into 3 and even 4. And the wild weather doesn't end there, because the hottest planet in the solar system even has snow, but not as we know it.
All of a sudden in the radar images, all the mountains go white. Now that's because there's some kind of highly reflective coating. It wouldn't look white to your eyes if you could actually land on the surface of Venus. It might look shiny because we actually think it might be some sort of metallic coating, almost like a pyrite or a fool's gold. So something sparkly, which to me is even better than looking at snow.
These are just some of the puzzles that the European Space Agency's Venus Express, now in orbit, is hoping to solve. As we begin to understand how carbon dioxide controls our climate, there's never been a better time to learn lessons from our neighbor.
What we're trying to solve now, with this very, very dense atmosphere, very complex weather patterns, with the new data from Venus Express, we're really learning by mapping out in 3 dimensions how the atmosphere behaves.
Unprotected by a magnetic shield, Venus is still being robbed of precious water. Venus Express has seen how the solar wind eats away at the atmosphere.
We can see that even today, that actually water is still escaping in the form of oxygen and hydrogen. And that's an indication that there has been water on Venus in the past.
Despite all this scientific effort, we still don't know what triggered Venus's diabolical transformation.
People debate over whether Venus ever had a moon. If Venus had a satellite at one point, could that satellite have eventually impacted onto the surface, caused some catastrophe to happen? We don't know. It could have been possibly a factor.
Perhaps such an impact explains both the strange calendar and climate on Venus. Was it hit hard enough to flip upside down? And for its day to be slowed to a crawl? Was this the moment Venus's climate was thrown into chaos? Whatever the cause of Venus's climate calamity, could life have ever survived such an ordeal?
If I had to guess or I had to bet, I would say, yeah, Venus did have life. And I say that because what we do understand about life on Earth is that it started early and doesn't seem to have required any extraordinary conditions. If there was life of our kind, the organic kind, on the surface of Venus a long time ago, then what happened to that life? Well, one possibility is that it just died out. But there's another possibility that's a little more exotic, which is that it may have migrated up into the clouds.
There's some speculation that Venus might actually still harbor life, even though it is such a hostile place. And the reasoning is that, well, gee, at one time, Venus was like the Earth in the first 2 billion years or so of its history. So if life were to grab a hold, maybe life was able to stay ahead of the environmental disaster that befell Venus as the water basically left the planet.
Could life really exist in the clouds of Venus? The best way to know for sure is to float into the atmosphere and find out.
Right behind us is the Valor balloon, which we intend to fly in the skies of Venus in a couple of years from now.
Valor will be tackling the acid clouds of Venus with a little help from frying pan technology.
There's been 2 other balloons already launched to Venus in the mid-1980s. These were the Vega missions. There were 2 separate balloons that the Russians put into the atmosphere. And one thing they knew to do was to put Teflon on that whole balloon. And the balloons worked perfectly for 2 days, just as designed. And so we know that Teflon works.
Battling violent updrafts and acid clouds, these non-stick pioneers were swept nearly halfway around the planet. Kevin expects Valor to go further.
We'll circumnavigate the planet, that is, fly around the world of Venus, not just once, but up to 5 times. And if we do that, and if we accomplish that, we will by far have the world's record. Actually, it's the universal record for flight in the skies of any planet anywhere.
Underexplored and unbelievably alien, the hot zone planets are finally being recognized as prime space travel destinations. Mercury, a planet that's both freezer and furnace.
As a geologist, if I could just bring back one rock, one sample, I mean, that would increase our knowledge of Mercury by, you know, tenfold or something.
I would like to go to these polar craters and figure out what is it. Even if it's not water, it's something very unusual and very fascinating.
And Venus, our unfortunate twin sister.
What we'd like to do is explore the regions that haven't been explored before. And so I would pick Alpha Regio here. That's probably the first place I would go.
I'd love to go see those snow-filled mountain peaks, with metallic snow, and see if we can figure out what's going on there. Maybe some new sports that could be created sliding down those metallic snows.
And then, of course, there's the future story and what's going to happen to Earth in the distant future. And that's another reason we're really interested in Venus, because the ultimate fate of the Earth is to look like Venus looks today.
Venus and Mercury, 2 planets of wonder, but trapped in their own alien hells. Perhaps not obvious destinations to discover more about our home planet. But that's the beauty of traveling the solar system. It's just full of surprises.